Hello everyone, this section introduces the database and tag functions of SOLISCADA software. First, let's take a look at the SOLISCADA database. SOLISCADA database includes real-time database and historical database. The real-time database is the core of the SCADA system. It is mainly used to collect data in the production process. It's collected and processed in seconds. For example, data processing such as range conversion, alarm calculation, and secondary calculation. It also provides data services and push data to the SCADA HMI client. The historical database is used to store the production process variable data collected by the SCADA system, which is compressed and stored, and provides query services to the SCADA client. Here, let's take a look at the database configuration. Open the SOLISCADA Configuration Management interface. We can see the database node. Double-click this node to open the database configuration interface. On this configuration interface, it has two parts. The part on the left is how the data interface is accessed and the communication protocol. The section on the right shows a list of all the tags for the data access. Double-click the node of history trend. You can open the configuration interface of historical data storage. In this configuration, you can add label items of the label data you need to store. Configure historical data storage policies simultaneously. Overall, the database configuration is divided into 4 parts. The first step is to configure the information of the collected device. The second step is to configure the information of the device points being collected. The third step is to configure the pre-processing information of the points, such as range, secondary calculation, alarm limits, and data grouping. The fourth step is to configure the historical data recording information, storage period, and compression accuracy. I/O driver and tag. An I/O driver is a software module in the SCADA system software. This software module implements an industrial communication protocol and mainly realizes data collection and communication with PLCs and external devices, such as Modbus, OPC, IEC 104, MAC-T, Siemens S7 protocol, etc. One driver module supports one communication protocol. The I/O drivers in the SCADA system can be extended in a standard framework and can be developed and implemented independently. A label is also called a variable label. It refers to the data points in the devices accessed by the SCADA system, such as the temperature, pressure of boiler equipment, and some internal parameter variables. Here, let's take a look at the I/O driver. In the database management, we double-click this node, and the I/O driver list will pop up. In the I/O driver list, it lists all the industrial communication protocols currently supported by the system, and some models of external devices. Then select the corresponding communication protocol module to achieve data docking and collection of external devices. Let's take a look at the general configuration of an I/O driver. Take the Siemens S7 driver as an example. Its common configuration includes name, scan cycle, reconnection cycle, device IP address, port, whether it is redundant, slot number, and SAP. Let's take a look at the general configuration of a tag. Let's take analog tag as an example. Its regular configuration includes name, description, I/O address, grouping, read-write attribute, unit, number of decimal places, range, etc. The basic attributes of tags. We know that data types include float, bool, integer, and string. The name of a label is mainly represented by English and numbers. Its maximum length is 256 characters. Description is used to describe the specific meaning of this label. I/O address refers to the data of this tag. Which communication protocol or device or driver? It is a communication path, the grouping and partitioning attribute of the tag used to manage tags. Read-only, read-write properties to define its read-write properties. The unit represents the unit information of the data. The number of decimal places represents the number of decimal places for analog data. Range conversion is to achieve the expansion and contraction of the tag range. The clamping value defines the safety limit of the tag value. Range conversion. So for an analog, we can turn on range conversion to enlarge or reduce the data range. Then the value of the data will change as this range is converted. The calculation formula after data conversion is defined here. The alarm function of the SCADA system means that when a device fails or an abnormal situation occurs in the production process, the system can send an alarm signal in real time to notify engineers to handle it in a timely manner, so as to prevent production interruption caused by device failures and ensure the continuity of production. The definition of a tag data value alarm in SCADA system includes the following parts. Limit alarm generally used for monitoring analog numbers, such as temperature and pressure. Digital alarm generally used for monitoring device status, such as abnormal pump shutdown. Rate of change alarm generally used for monitoring reaction processes, such as rapid pressure changes or rapid temperature changes. It will give a change rate alarm. Alarm priority to define the severity and priority of the alarm. Alarm hysteresis value. Alarm value buffer to avoid alarm nuisance caused by minor disturbances. Alarm shielding. Under certain working conditions, such as during equipment maintenance, you can block the alarm through this function to avoid some useless alarms. Alarm delay. Alarm time buffering to avoid small disturbances causing alarm nuisances. Secondary calculation variables. Secondary calculation refers to the further processing and calculation of the data. Calculate the value and obtain new data through the calculation formula. On this interface, we can click the Select button to pop up the editing interface of the calculation formula. On this editing interface, we can select various calculation methods. At the same time, click the Label button. We can select the variables labeled by the system in the database to be added to the computation. Cumulative quantities are to accumulate a certain amount of data, such as the accumulation of flow and electricity. It needs to be associated with a specific tag variable to achieve data accumulation. Accumulation can be triggered in two ways, according to data changes and time timing. One of its features is that it is read-only and cannot be written. At the same time, the configuration of its alarm is the same as that of regular variables. The following is a simple demonstration of database functionality. Open the project management software and open the project. Here we can see the node with a database. Double-click on this database node. We can open the database configuration interface on the left side of the configuration interface. We right-click and select Add Driver. It will pop up a list of driver options. We choose the required driver according to the actual needs of the project. For example, let's choose a Siemens S7 driver here. Add it in. Double-click the configuration node of this driver, and the configuration interface of this driver will pop up. We can add a device here. This device is a PLC that needs to be communicated and collected. Here we can choose the model of the PLC, S7200, 3 4 1200, and so on. These settings here can be default settings. Here, you need to configure a set of PLC Internet Protocol addresses. This Internet Protocol address is the actual Internet Protocol address of the PLC. After configuration, you can close this interface. The next step is to add data and tag. I'll do a simple demonstration here. The data types include real, string, switch, and integer. Let's choose real one. Select an I/O address here. The I/O address is actually the address map to the memory area in the PLC. Here, you can select the data block, DB, QM, and I areas. So if it's a DB area, it has a serial number, such as DB1, DB2, and so on. Fill in one of its offset addresses here. For example, the first offset of DB1. Click OK here to generate an address. And these are the groupings of its tags, unit of data. Read-only or read-write. Whether to disconnect and keep. If the data is broken during communication, and its data can be maintained. This is a range conversion function. Click on this page, it has some alarm line settings. A total of so many alarms can be set. The variables here are added. Click on the extended variable. Add a quadratic calculation and cumulant. Quadratic calculations can do a numerical calculation of this. Click Select. Here, you can do some numerical calculations. Select the data just now. Let's do an addition. And that's the second calculation. Or you can accumulate data. Or you can choose this data for accumulation. You can choose whether to accumulate after the change or accumulate according to the time period. We will use the cumulative change. and add it. This is the basic data addition and database operation. Meanwhile, if we want to store this data in history, you can find that historical trend node. Double-click to enter. I can add this data. And add these tags. Add the historical server here. Then check the packet partition of the tag that needs to be recorded. This is the configuration complete. Okay, this is a demonstration of a function.